Geometry 1-1, points, lines, and planes. If you don't have this packet, it's okay. You can just use regular paper. It just might be a little bit more writing for you. We're going to just get right into this. We're going to first talk about these undefined terms. Undefined terms. Don't worry about this part so much. This next part, though, is going to be important and is going to be these terms that we're going to learn, we are going to be using quite a bit throughout the rest of the year and the rest of your math career. So it's important that you learn these terms here. So a point is a location. It has neither shape nor size. It is named by a capital letter. And so an example over here would be a point, and we'll call that point A. A line is made up of points that has no thickness or width. There is exactly one line through any 2 points. Remember, we learned what a point is up here. It is named by a lowercase script letter or by the letters of the points which the line goes through. So let's draw a line over here. This probably, we should say points. Which line goes through. So if I have this line, I'm going to call it line T. So I make a lowercase script t, and I have a point here that is point M and a point here that is point N. So there are multiple ways that I could name this line. One would be saying line T. You could also call it line MN. You could call it line NM or MN, either one. You could go like, you could draw it like this, MN with a line on top of it. Notice there's an arrow on both sides of that. Or NM, line on top, arrow on both sides. The line goes on forever in either direction, in both directions. All right, we got a point, we got a line. Now let's talk about a plane. A plane is a flat surface that extends indefinitely which means forever. It just goes on. It's not, the end is not defined anywhere. Even though we draw it as kind of a parallelogram or whatever, it's still not, these edges go on forever in every direction. They don't actually stop here. Excuse me. There is exactly one plane through any 3 points not on the same line. It is named by a capital script letter or by the letters with which the plane goes through. So let's look at this plane over here, and we're going to say this plane has points in it C, B, and D. Notice they are capital letters because they name a point. This is plane K. So I do like a capital script letter there, K. So there are 2 ways that we're going to talk about. You can name this. You can name it plane BCD, or you can call it plane K. Either one of those are appropriate. And these can be in any order here, the letters. Okay, so those are definitions that we're going to be using throughout geometry and into all of the other math classes that you'll be taking. Now we're going to talk about a little bit more terms here, and then we're going to do some examples of all this. So collinear points are points that lie on the same line. Collinear, see how it says line in there? Collinear, same line. If they're not on the same line, they are non-collinear. Now, coplanar points, coplanar, are points that lie on the same plane. So you've got almost the word plane in there. That's to say, look, coplanar means points are on the same plane. If they're not on the same plane, they are non-coplanar. All right, so those are the terms. Now let's figure out how to use these terms. So first we're going to, I'm going to give you some letters here, some names for these points and lines, and then we'll do some examples. So this line here is line N. So lowercase script letter for line N. This line here is line R. We're going to have a random point out here called point Z. This point here on the upper left hand side here is V. The one next to it is W. Right here where these two lines intersect is X. This point here is T, and the point down here to the right is Y. Now, real quick, just to make sure, just to be clear, this arrow is not a point. This is not point N. N refers to this whole line that goes forever in either direction. Same with this R. This is not arrow R. This is line R that extends forever in both directions. All right, let us finally do an example here. So use the figure, this figure, to name the following: a line containing point W. So I'm looking for point W, and here it is. And here's a line that is containing point W. So I'm going to call that line N. Now, we could also call this line line VW. We've got VW here, so that line is there. We could call it WV. We could call it VX, because look, oh, not X, yes, X right there. VX. We could call it XW. These are all names for the same line. We could call it YX, YW, YV, any of that stuff. As long as you have 2 points on this line, you can name that line that way. Okay, you try. So for a you try, I'm going to set up these questions for you, and then you're going to pause the video and try the questions. And then when you're done doing that work, unpause, and I will work through the answer or with the problem with you. So for B, you're going to do a plane containing point X. So you're going to look for a plane that has point X, and then you're going to also try to find a plane that contains points T and Z. This one's going to be kind of tricky. So you got to look maybe back up at your definitions up here on the top to help you figure that one out. Okay, go ahead and pause, and I'll be right back. All right, so a plane containing point X. All right, so I'm gonna look at X, find X, there it is. X is in this big plane here. Now this plane doesn't have a name as far as like a capital letter goes. So we've got to name it based on the points that are in the plane. So here is X. And let's see here. We're going to need to, we'll call this plane, a plane containing point X. Plane. Now here's a tricky thing here, because notice how all of these points that are in this plane, all the points that are contained in this plane are on the same line. So remember back here, we find that there is exactly one plane through any 3 points not on the same line. So that means we've got to figure out where a different plane is based on 3 points. So I've got X, and so I'm going to say, okay, X, Y, and T, they would make up a plane, because I have 3 points that are not all on the same line. It's okay if 2 of them are on the same line, that's going to happen. But all 3 of them need to not be on the same line together. So I'm going to say plane XTY. You could say plane WXT, VXT, ZXY. Any of those would be okay as long as it's 3 letters and one of them is X, and the other 2 are not all on the same line with X. All right. Similarly, we've got plane TZ, and then we need to find another letter or another point that is not on the same line as T and Z. So I've got T and Z here. I can choose any of these points, and none of them are going to be on the same plane as T and Z. So I'm going to say plane TYZ. All right. Hope you guys did all right on that those U tries. Let's keep moving here. Intersections of lines and planes. So let's go ahead and fill in some blanks here and then do some examples. So the intersection of 2 or more geometric figures is the set of points they have in common. Okay. So think about it for a second here. If I have 2 lines that that intersect like this, well, say I have 2 pencils, how many points are they going to have in common? Hopefully you just say 1, because that's where they cross. If they cross like this, then they'll have all of their points will be in common. And if they are like this, where they're parallel, then they won't have any points in common. So this one, they intersect at just 1 point, and this one they would intersect at all of the points, and this one they would not intersect at all. All right. Let's go ahead and graph some points. So I'm going to have A, which is -2, 4, B, 0, -2, C, -3, 0, D, 3, 3, and F, 2, -3. So let's just plot these points here on this handy-dandy coordinate plane we have. So A is -2, 4, -2, 4. Man, someone was really nice to you guys and laid up this coordinate plane like this with the numbers here and everything. 0, -2. That's B. And C is -3, 0. Notice I'm labeling my points as I plot them. D is 3, 3. E is negative 1, 1. Oh. No. I'm not telling you what E is yet. Sorry. Okay, F. 2, negative 3. 2, negative 3 is F. We're not getting E yet. I'm not giving you E yet. You'll get it soon though. Label. Okay, so draw AB, line AB, and line CD. All right, so you might want to use a ruler for this, or you might just want to be careful with your the way you draw it. I like to use a ruler when I have one available. So I want line AB. So line AB, so I find those points A and B. I draw a line. I draw arrows on either end. That's how I know it's a line. And then CD. If you don't have arrows, then it's not a line. It's a line segment. And so if you don't have the arrows on your test or whatever, you might lose points for that. Now, the next part of this is you're going to label the intersection, point E. So I look at my two lines here, I see where they intersect, and right there at negative 1, 1, that is point E. All right. Now let's look at something real quick here. What if I had? I want you guys to draw a plane. And it's kind of like a rectangle that's been flattened. And we're going to say this is plane T. And let's draw a line through this plane. So we're going to say that it hits the plane right here, and then we'll make a couple dotted, make the line dotted right there, so that it looks like the plane hit there, and now the line hits the plane here and now is going behind it and keeps going. And so this point here is S, this point up here is Q, and this point down here is R. Now, I want you to say out loud, what is the point of intersection between this line and this plane? Let me hear it. Did you say S? Intersection at point S. So hopefully you said S, and people are looking at you kind of weird if they're in the room and they don't know why you're saying point S, Mr. V, point S. Okay, we've got one last little bit here. And that is interpreting this drawing. So you might have something like this on the homework or on the test. We're going to label this, and then I'm going to have a few questions for you. So up here at this vertex is D. Right here on this line segment is K, about halfway down. And then down on the base here is J. And then making our way around is going to be H, G, F, and then back here is going to be E. This is going to be, this intersection here is L. And then we're going to add another point here, point M. And this plane that all this stuff is going through and on top of is plane X. Capital script letter, plane X. Okay. We've got two questions here. how many planes do you see? Okay, so I've got this plane back here, 1, this plane here, 2, this one, 3, this one in front, 4, DJH, 5, and then this plane here, which is 6. Now, we're going to say 6, but we could do a lot more planes than that. We could do DLF, we could do DLG. We just need three points that are not collinear, and we can make a plane from that. But for this question, we're just doing the planes that are shown. All right, name 3 collinear points. Okay, name 3 collinear points. So remember, 3 points have to be on the same line. And so I can look around here. This one has 2 points. This has 2 points, 2 points, 2 points, 2 points, 2 points. Oh, here's 3 points. JKD, 3 points. J, K, and D. Now, really, if this is a lot, well, anyway, let's keep going. Name, one last thing. Name the intersection of plane HDG with plane X. Okay, so let's find our 2 planes that we're talking about. So plane X is this big rectangle plane. Plane HDG, so let's find that one, HDG, so we're naming it by these 3 points. HDG, so that's this plane right here out front. So we need to name the intersection of the plane, of the 2 planes. And anytime 2 planes intersect, they form a line at their intersection. So that means that here HDG intersects with plane X at HG. Line HG. Or you could say line HG. And that, my friends, is 1-1.